Okay, we are back. Well, we are not back. It's just like the first video I'm doing it for you guys. I've been doing a lot. This is like the sixth video. Okay. After what we've done with the trigonometry, the sine, cosine, tangent, we are going to move back a little bit to chapter 6. But because of the time limit we have, I am not gonna go through the same thing as what we would normally do. Period 6 is going to be condensed. Alright? It's going to be condensed as in like this. Oh, like this. So there are altogether 6 little topics. We are not gonna do all 6 of them because let's say this one is the same thing as 6.5. So what we're gonna do is quite probably in this lesson or two, I'm gonna condense this whole chapter 6 into 2 lessons. And I think that the ambition is dragging along. I don't like it. So this video is gonna be quite simple. I'm just gonna start with this and then we will move on to parallelogram. Basically, chapter 6, in an abstract, is all about parallelogram. Different types of parallelogram, rhombus, kites, and square, and rectangle, all that kind of things. And they all come with a property or two that so you can distinguish one thing from another one. So that's basically the topic itself. However, 6.1 is a little bit odd, as in it's not about polygon, it's not about parallelogram, it's more about just in general, like polygon. What does it mean by like a polygon? So 6.1 is going to be a very short video. What you have to do after this video, there will be a little quiz on Schoology for you. It's all about finding the interior and exterior angle of the polygon. And this screen that you're looking at is the concept summary of 6.1. Basically in there, they will talk about 2 theorems. Is the interior angle theorem and the exterior angle theorem. In fact, I should change the color because I'll let you know why. Personally, I don't really like this one, the interior angle theorem. I just think this is too clunky. It's really no point to remember a formula unless you really want to. We normally want to carry around like concepts that are easy to apply instead of remembering a formula, because there's always a chance that you'll remember it wrong. Maybe you keep remembering it's like n-3 and then you get the interior angle incorrect. So what I want to say is don't do that. So I'm going to talk about the exterior angle theorem extensively, and then we are going to I'm just going to teach you how to use that to find all the so-called interior and exterior angle. I want a new one. I don't want to stay with this exterior angle theorem. Okay, exterior angle theorem. Should I change the background? Graph. So let's change the background because I don't like it. So exterior angle theorem basically says for any kind of polygons, there's always a way to find out one exterior angle, what it will be like. Because our focus will be mostly on regular polygons. It does apply to other polygons as well. So I will give you the condition later on. And it's hard. Oh, yeah, okay. Center is fine. Okay, so let's say exterior angle theorem. What does it mean? Let's just talk about polygon on its own. So if I click on this, all of these are polygons. There's a polygon. There's a polygon. there's a polygon. Some of them we have names for it, some of them we don't, or some of them I just don't remember. It doesn't really matter. We can actually count. So there's a three-sided polygon. When we are talking about polygon, suddenly we don't really talk about the name itself. It's three-sided. 1, 2, 3, 4, 5, 5-side polygon. You know, some of them have the names. If you remember, good for you. Okay. For all of these polygons, oh, furthermore, I should tell you this term. Converse polygon. Converse basically means each of the individual angle is less than 180 degrees. So something like this, all these angles, they're less than 180 degrees. So we normally focus on this group, and in particular, we are focusing on regular polygons. Regular polygons, if you do not remember, in chapter 2 we actually talk about it. Regular polygons basically means that all the sides are the same, and all the angles will have the same side, same measurement as well. So all of these are the same. Makes it very easy to work with. We like shapes that are symmetric. We like things that are equal. That's just wonderful things. Okay, so we are dealing with regular polygon. The biggest things that they may ask you is what is the angle measurement of like either the exterior or the interior angle. Interior angle is all these red angles over there. They will call that the interior angles, and then sometimes they'll talk about the sum of the interior angles. And just by knowing the exterior angle theorem is going to carry you further on. So exterior angle will be things that are in green. So if I extend any of this side, the green is going to be the exterior angle, the green is going to be the exterior angle, the green is going to be the exterior angle. Okay, this is just too much, but I'll do it anyway. So all of these have a nice setting going on. So the exterior angles are those things in green. Now, one thing very interesting about this exterior angle. Let's see if I can perform that for you guys. So let's say I grab this. And I'll grab the last one. Okay, if I put all three of them together for a triangle, this will sum up as a circle. So a circle is going to be 360 degrees. Alright? A circle is going to be 360 degrees. So basically the exterior angle theorem basically says if you pick all the exterior angles out and you add them together, the sum is going to be 360. And because we are dealing with regular polygon, and the exterior angles are all going to be the same, so for the exterior angle of a circle, I mean a triangle, a three-sided polygon, each exterior angle is going to be 360 divided by 2, not 2, 3, is 120, right? So each of these is going to be 120. Okay, because it's regular polygon, so all of this is going to be 120. That's going to be 120. That is going to be 120. So this method is very useful because you don't have to carry around a formula that you may remember it wrong. And because you know the exterior angle, you will be able to find the interior angle because this is just a straight line. Remember that we're extending this. So if this is 120, then the red is going to be 60 degrees because it's just angle on a straight line, right? This is 120. The other one has to be 60 degrees. And so that makes our life a little bit easier. It's because now I can talk about what is the sum of a triangle, right? Triangle sum. Even if you don't use the theorem, now you know that because a triangle has three interior angles and each of which is going to be 60, therefore it has to be 180. And so that is how we develop theorems like that. We started off with regular polygon. And then because the exterior angle theorem is going to apply to any kind of polygons, it doesn't have to be regular. It's the sum of the exterior is always going to be 360. Then we ended up with this scenario. That's how we find the sum. The triangle sum is going to be 180. And subsequently, any other shape is going to work. Any other shape is going to work. This is 1, 2, 3, 4, 5. So each of these angle is going to be, let's use green. Each of this angle, the exterior angle, is going to be 360 divided by 5, right? 72. So each of these is going to be 72. So the interior angle, the one that's in red, is going to be 180 minus 72, which is 102. Alright, so each interior angle is 102, and so the sum is going to be 102 times 5. Oh, suddenly I cannot do math. There you go. So it's 510. It's 510. So this method is very, very useful. So you don't have to carry around that, I would say, personally, the interior angle theorem or something like that. I never really remember that because it's just a clunky way to find the sum. In fact, if you understand the concept of exterior angle on its own on any kind of polygon, what you can do is with this simple method, you'll be able to find it. Just do one more example. Maybe I shouldn't because I'm gonna set a test for you guys. Let's just do one that I will not ask you. Maybe 10. Okay. So this regular polygon has 10 sides. Or any polygon with 10 sides is going to work. So the exterior angle, let's just extend one of these a little bit. So each of these exterior angle is going to be 360 divided by 10, 36. Okay, this is 36. So the other side has to be 164, right? No. Oh, 1 second. 54. 44. Jesus. Don't do math on a Saturday at 1:05 p.m. Did I do it right? Yes. I do it right. So for this, because each of the interior angle is 144, so the sum of this is going to be, because it's a 10 side, it makes it very, very easy. 1440. So that will be the total for any kind of polygons. If you're unlucky enough to run into a diagram that is not regular, and you have to somehow find the angle measurement, that's how you get to the sum. Okay, we've seen why the sum of a polygon is very useful, because we've been doing like sum of triangles. Let's say this is 90, that's 30, then we can find the last one. That's why you can get to the sum of triangle without, remembering anything. You just need to know the exterior angle will add up to a circle. So this is a very short introduction of this chapter. Because I did this, so I'm going to set up a very simple Schoology quiz, and I don't think you need assignment for this. So if you get the quiz done, and you better get 100% on it, we move on. So as I said, I'm trying to condense 2 with all these things in 2 lessons. Could be shorter, and basically, this is only 15 minutes. The quiz lasts 2 minutes, and then we move on. And hopefully we can just get this whole parallelogram thing out. It's really nothing. So bye for now.